we are learned last week. So actually for DC bridge actually is to measure the resistor, okay? To measure the resistor. That is the function of the DC bridge, okay? The function for a bridge actually is to measure the resistance, inductance, capacitance, and also we can measure the frequency. All right. For DC, we can measure the resistance, and then for the AC, we can measure the inductance and capacitance. All right. So will be covered for today. All right. So for DC bridge, actually we have two types of DC bridge. First, we have Wheatstone bridge, and second one we have the Kelvin bridge. Okay, for the DC bridge lah, we have two type of the bridge. Okay, one is the Wheatstone bridge. Okay, so you can see this one. So this is Wheatstone bridge. All right. So another one is the Kelvin bridge lah. I think all the bridge actually based on the Wheatstone bridge lah. Okay. Almost similar like for example like Kelvin is almost similar like the Wheatstone bridge. Okay, right, so the basic of bridge is the Wheatstone bridge lah. Right, so this is that you have to remember lah. Okay, you have to remember to balance the equation, so you have to get this equation lah. 1 over R2 equals to 1 over R2 equals to R3 over R4 lah. Okay. Okay, so today we go dimension 2, we go for the AC bridge, AC bridge. Okay, so this is a Wheatstone application. Okay, we can measure the strain gauge. Okay, and then also we can another application for Wheatstone, we can locate the ground. Okay, locate the ground fault. Right, so this is some application using the Wheatstone bridge. Okay, so and then that I mentioned to you, another one is the Kelvin bridge lah. Okay, so similar like Wheatstone bridge, but on the different this part lah, right? On this part, so they have the add another RY here, right? So that is the Kelvin bridge lah. The concept will be similar like Wheatstone bridge, okay, for the Kelvin, but they're different on this part lah, on the RY. Okay, so they already have the formula derivation to get the value of the RAB, RCB, and so on. Right, so maybe you have to remember the formula, right? Formula for how to calculate the, for example, how to calculate the RX, and then also how to calculate the RAB and also RCB lah. Okay, so for today we go for the we go for the AC bridge. Okay, so on the AC bridge, actually we have 4 types. We have 4 types of AC bridge. Okay, so for example, we have the Maxwell bridge. Okay, we have a Hay bridge. Okay, we have the Sharing bridge, and also we have the Wien's bridge. So on the AC, we have 4 types of the bridge lah. All right, so the function of the AC bridge is to measure the inductance, capacitance, and also we can measure the frequency. All right, so this is the function of the AC bridge. Okay, compare with DC, DC just only measure the resistor. All right, measure the resistance. Okay, for AC, okay, we can measure the inductance, capacitance, and also we can measure the frequency lah. Okay, you can see this one based on the Wheatstone bridge they mentioned to you. So the okay, for AC or for DC, for example, like Kelvins, all right? So that's why you have to know the basic bridge is the Wheatstone lah. All right, so for AC, you can see on the figure here, okay, on the figure here, they use the inductance, okay, they use the impedance, they use the impedance lah. All right, so the impedance consists of resistor and inductance or capacitance lah. Okay, for example, like DC, okay, DC they use the R. All right, for AC they use the Z. Okay, Z is the impedance. Okay, that impedance is consists of value of resistor plus, okay, plus minus with, okay, with we call that JXL, okay, this means the inductance or negative JXC, right? This is capacitance, right? So this we call the impedance. That means impedance consists of this one. Resistor is the real, okay.
Doktor,
Yeah, sorry.
slide tak nampak.
Oh, slide tak nampak. Alright.
Ah.
Such as we have the Maxwell bridge, okay, we have the Hay bridge, okay, we have the sharing bridge, and we have the Wien bridge lah, right? So actually, so for AC is to measure the inductance, capacitance, and also we can measure the frequency lah. That is the function for AC bridge, okay? Actually, the AC bridge also based on the Wheatstone bridge lah, alright? So you can see this one, this is similar like Wheatstone bridge. The difference is the, so for the Wheatstone bridge, they use the resistor, okay? For AC, normally we have the, okay, impedance, okay? Impedance is the Z. Okay, is the Z. Okay, Z actually is consists of the resistor plus minus of inductor or capacitor lah. Alright, so that is the impedance. Okay, that means the impedance we have the Z. Okay, we have the Z equals to R plus minus, okay, J omega XC or J omega XL lah. Alright, so either the inductance or the capacitance. That means the R is the real, okay, the real part, and the inductance and capacitance is we call the imaginary part lah. Alright, so that's why we call the impedance. Okay, the impedance, okay, Z equals to R plus, okay, plus J something lah, J impedance, J inductance or J capacitance. Okay, that is the impedance. Okay, so this one will be similar lah. We have the Z1, Z2, Z3, and Z4 lah. Alright, so for example, the Wheatstone bridge, normally we have the R1, R2, R3, and R4. Alright, so the detector can be paired of the headphone. Okay, this one, we can use the headphone, okay, to and we can use the Lisa Joyce figure. That means we can use the oscilloscope, and also we can use the electrogalvanometer lah. So normally we use the galvanometer. Okay, we use the galvanometer here for the detector lah. Alright. Also we can use the Lisa Joyce figure or headphone lah. So but I mentioned to you, so normally we use the galvanometer lah. So if the bridge is balanced, okay, that's you have to remember lah. The formula, formula for if the bridge is balanced, that means here Z1 over Z3, right, equals to Z2 over Z4. That is the bridge is balanced, that you have to remember. And then you can cross multiply. Okay, you can cross multiply Z1 multiplied by Z4 equal to, okay, Z2 multiplied by Z3. We call the cross multiply, right? So similar like this, Okay, so this is we call the Maxwell bridge. Okay, so the Maxwell bridge is, this is cut for Maxwell bridge lah, right? You can see this one, So the difference is compare than Wheatstone bridge. Okay, so we have the, here will be same. We have the resistor. Okay, the impedance is only the resistor, and also this one, this one will be R3. Okay, you can change on your slide. So this one is the R3. It's not the C3. It's the R3. So some mistake here. Okay. I did typing error here. So this actually is the R3 lah, is the variable resistor. Alright. So the difference is on the R1 and R4. Okay. So this one will be Z lah. Okay, we call it Z1. Okay, Z1 here we have the R and parallel with C, parallel with capacitor lah. Okay, with capacitor. And for R4, okay, for the Z4, okay, is equals to Rx plus with Lx. Okay, that is for impedance 4. Okay, impedance 4. Alright, so from the circuit, balance circuit, so we can get like this lah. Alright, Z1 multiplied by Zx. Okay, this one we call the Zx lah. Zx equals to Rx plus Lx lah. So for Zx, okay, equal to Z2 multiplied by Z3. Okay, this is balance lah. Okay, the balance, and then we want to find the Zx. Okay, Zx, okay, the equation will be Z2 multiplied by Z3 over Z1. Alright, Z1 here. So and then or equals to Z2 multiplied by Z3 equal to Y. Y is the emittance. Emittance is equals to 1 over Z. Okay, that is formula for emittance. Okay, emittance is equals to 1 over Z lah, Z, or 1 over Z, and that's why you can get this one emittance 1. That means this one, okay, 1 over Z1 lah. That's why you can get this one Y1 here. Okay, this we call the admittance. Okay, admittance is the 1 over impedance. Okay, that is for admittance lah. Alright, so you can see this one for Z1 is equals to R1 parallel with C1. You can see this one for Z1 here. Alright, so and then the Y1 is equal to 1 over Z. So this is for impedance or admittance. Admittance for Z1. Okay, 1 over R1 plus J omega XC. Actually, is the if you put Z here also can, also can, but this one will be R1 over 1 over J my omega C. Right? So that is for capacitor. Alright. So for Z2 is equal to R2 lah. Okay, Z2 is equal to R2 because no imaginary part. That means no inductance or capacitance. And also the Z3, Z3 also R3. Okay, also this one, So, but the R3 is the variable resistor here. Okay, so for balance dimension to for balance this one, alright. So normally we adjust the R3 so that our galvanometer will indicate the no or the zero indicator. Then we can get the value of Rx and Lx. Okay, so the Zx is equals to Rx series with Lx here. Okay, series. So that is the for Zx lah. Rx plus J omega L. Okay, J omega Lx. Okay, and then substitute this value. Alright, substitute the Z1, okay, Z2, Z3, Zx to this equation. Alright, to this equation you can get like this lah. Alright, so Rx plus J omega Lx, okay, equals to R2 multiplied by R3, okay, multiplied by 1 over R1 plus J omega C1. Right, so this one from this formula. Okay, we substitute this all the value here to this equation. Okay, to this equation we get like this, and then we can compare with real with figure. That means real part Rx is equal to this one, to this part, and imaginary part we can compare with imaginary part. Okay, that's why after we get this equation, okay, just compare the real part. That means Rx with this value. Okay, that means Rx equals to R2 multiplied by R3 divided by R1. Okay, on the real parts. And then for imaginary, J omega Lx equals to J omega C1 multiplied by R2 multiplied by R3. Right? And this one, so that's why I mentioned to you. So you just compare the real terms and imaginary terms. Okay, that means compare with the real part and the imaginary part lah. Okay, this is for real part, and this one for imaginary part lah. Okay, and then from this one we can calculate the Q lah. Okay, the Q value. Alright, so actually the Wheatstone, the Maxwell is to measure the unknown inductance for the low Q value lah, low Q value, the range from 1 to 10 lah. Alright, so the formula to calculate the Q using this one, the formula will be omega Lx divided by Rx, and then we substitute the Rx here and Lx here, so we get like this lah. Okay, and then we can cancel out the R2 and RT here, so that's why Q equals to omega multiplied by C1 R1. Okay, that is formula to calculate the Q. Alright, so that is for function for Maxwell. Okay, the function of Maxwell is to measure the inductance that I mentioned to you, measure the inductance for the low Q value lah, the range from the 1 to 10. Okay, right, so that is the function for Maxwell. Alright, for when you calculate the Q more than 10, that means this is high Q factor. We cannot use the Maxwell. So we have to use the another one lah. We call the Hay bridge. Okay, the Hay bridge. So the function of Hay bridge will be similar like Maxwell. Okay, to measure inductance, but okay for the high Q value lah. That means the Q coil. Okay, so this one for Hay bridge, the function is to measure the inductance for the high Q value. All right. Okay, so you can see the difference between the Maxwell and Hay is on this part. Okay, on this part, on the Z1, So for Maxwell, normally R1 parallel with capacitor. Okay, but for Hay bridge will be series. Okay, will be series. R1 series with capacitor 1. Right, so that the different The rest will be same. You can see R2 will be same, R3 will be same. Is the variable resistor and also R4. So that means we call it Z4 lah. Z4 will be Rx plus Lx. Okay, will be same. But the difference only for Z1 lah. Okay, so for impedance 1 for impedance 1. The equation will be same, but the difference on the dimension to you different on the Z1 lah. So the Z1 equals to R1 okay minus J over omega C. Okay, omega C1 lah. So that is formula for impedance Z1. And then R2 okay will be Z2, okay, Z3 will be R3, and also Zx will be Rx plus J omega Lx. Okay, and then same, we use the balance equation here. Okay, balance equation here, and then substitute the all value lah. Okay, the all value So this is for Z1 multiplied by Zx equals to okay R2 multiplied by R3. That means Z2 multiplied by Z3. Okay, this one Alright, so from this equation, so we have to derive lah. Okay, we have to cross multiply lah. Okay, for example, R1 multiplied by Rx, R1 multiplied by J omega Lx, and then J, okay, negative J over omega C1 multiplied by Rx, and then last one J over omega C1 multiplied by J omega Lx. Okay, so it will be like this lah. And then after you cross multiply here, okay, and then you can compare lah. Similar like Winston, you can compare the real and imaginary part. Okay, this is for real. Okay, this is the value for real. That means R1 multiplied by Rx equals to Lx over C1 equals to R2 plus multiplied by R3. Okay, and then this is for imaginary. Imaginary, okay, Rx over omega C1 equals to omega Lx R1. Okay, this is for imaginary part, and this one for real part. Okay, the real part, the real value lah. That means the here will be real value, and this one will be imaginary value. Right, and then we have to solve the Lx and Rx lah. Okay, Rx we have the Rx equals to omega 2 Lx C1. Okay, C1 because of this one we just cross multiply here. Okay, cross multiply, that's why you can get omega power of 2 Lx C1 R1 lah. Okay, and then substitute this Rx to this equation lah. Okay, to this equation, and then we get like this lah. Okay, and then from this equation we can simplify to this equation to simplify to this equation. That means to calculate the Lx equals to R2 multiplied by R3 multiplied by C1 divide by 1 over omega power of 2 R1 power of 2 and C1 power of 2. That is for calculate the Lx. And then to calculate the Rx, this is formula lah. Okay, formula. Alright, so equals to omega power of 2 C1 power of 2. Okay, R1 multiplied by R2 multiplied by R3 over 1 plus omega power of 2, okay, R1 power of 2, C1 power of 2. Alright, so this is formula for Rx, and this is formula for Lx. And then also we have to calculate the Q lah. Okay, the function of the Hay will be high Q factor lah. That's why you have to calculate from this one. You can calculate the Q lah. Okay, for the Q factor. This is formula for Q factor lah. So normally we can get the Lx, then the rest will be given. Okay, from this equation we can get the Q. So the Q will be height, okay, for the using the Hay bridge lah. Okay, that is the for the second bridge. So the Maxwell and bridge normally is to measure the inductance. Okay, they measure the inductance, but the difference is the for Maxwell is for low Q factor, and for Hay bridge it will be high Q factor lah. But the equation will be different. Okay, the equation will be different to calculate the Rx and also for Lx. Okay, for your part, maybe you just remember the formula. Okay, there is a standard. The Maxwell bridge is the standard. Okay, no. For example, we put another capacitor. No, there is a standard lah. That means for Maxwell only the for example the Z1 is the okay, R1 parallel with capacitor 1. Okay, for Hay will be series lah, will be series. Okay, the resistor will be series with capacitor. Okay, that's the difference between the Maxwell and bridge. Okay, right. So this is some example. Some examples. Okay, to calculate the Hay bridge lah. Okay, there is will be given. Okay, the value omega will be given. Okay, 3000 radian per second. Okay, R2 10 kilo ohms, R1 1 kilo ohms, and capacitor okay 1 microfarad. Okay, so and R3 is 1 kilo ohms, and then to calculate the Rx, just substitute the value lah. Okay, that is a standard formula. Standard formula for Hay bridge. Okay, so just substitute the value and then we get the Rx. Okay, Rx equals to 4.86 kilo ohms. Okay, that is for Rx, and then also you can use the formula to calculate the Lx. Okay, the Lx equals to R2 multiplied by R3 multiplied by C1 over 1 plus omega power of 2, R1 power of 2, and C1 power of 2 lah. This one for Lx. Okay, that is a standard formula. This is standard formula. Okay, for Hay bridge. And then just substitute the value for R1, R1, R2, and R3 and C1, and then we get the value for Lx. Okay, the value for Lx is just 270 millihenry. Okay, millihenry. This is for inductors lah. Okay, so this is the value for Rx and value for Lx. Okay, for Hay bridge lah. Okay, on the Z4. Okay, on the impedance 4. This one. Alright, so the next bridge for the AC is the sharing bridge. Okay, sharing bridge. Alright, so the sharing bridge is used for precision measurement of the capacitor. Alright, so sharing bridge is to use to measure the capacitor lah. Okay, I think so for sharing is just measure the small capacitor. Small capacitor with low voltage lah. That is for sharing lah. Alright. Okay, you can see so it will be based on the same concept with the Wheatstone. Okay, Wheatstone, but the difference is you can see this one similar like Maxwell. You can see similar like Maxwell because of the impedance Z1 will be same. Okay, but this one R2 will be actually is the same, but they use the resistor. Okay, variable resistor here. R2 will be variable resistor. Okay, the difference is this one this part is the on this part this part and this part lah also before this we want to measure the inductor, but for sharing brief you want to measure the capacitor. Okay, capacitor here. So this one will be C3 will be capacitor lah, right? But the same standard we have to based on the balance equation. This one based on the balance equation. Okay, Z1 multiplied by Zx equals to Z2 multiplied by Z3 lah, and then we want to find the Z3. Okay, Zx here, so we get like this lah. All right, so and then we can get the every impedance lah. For example, okay, Zx equals to Rx minus J over omega Cx, and then Z2 is equal to R2. Okay, and Z3 equals to okay only the imaginary part okay, because of no here for Z3 is no resistor, only the imaginary part capacitance or inductance. Okay, for this one they use the capacitance. Okay, the formula will be J over omega C3. All right, and then for Z1 is equal to 1 over Y lah. That's why we can get the Y emittance So y equals to y1 equals to 1 over r1 plus j omega c1, and then use all the value for z1, z2, z3 and z4, substitute to this one. Okay, you can get like this. Okay, and then after you calculate like this, we can simplify. All right, we can simplify this one. We can differentiate between the real parts and imaginary part. Okay, that's why after that we can compare real part with real parts and imaginary part with imaginary part. Okay, the imaginary part we have the j lah. Okay, if we have the j, that means this one we have the imaginary parts. Okay, on also this one lah. That's why you can see. So on the real part, okay, Rx equals to R2 multiplied by C1 over C3. All right, so that is for calculate the Rx, and for Cx equals to R1 over over R2 multiplied by C3. Okay, so that is calculate the Cx here. Okay, that is the standard formula. Okay, that is the standard formula for calculate the Rx and Cx for sharing bridge lah. Okay, so for example like this. Okay, we have an example. All right, so you can see this one. So all the value will be given here. Okay, so the R1, okay, the R2, okay, C3. We have to calculate the Rx here and Cx here lah. Okay. Okay, using the formula. So the straightforward. This one just straightforward using the formula. All right. For example, like to calculate the Rx. Okay, the Rx equals to C1 over C3 multiplied by R2. Okay, and then just substitute the value lah. C1, okay, 0.5 microfarad and divide by similar 0.5 microfarad. Okay, multiplied by 2k. So equals to 2k lah. That is for Rx. Okay, Rx, and then for Cx, okay, formula is 1 R1 over R2 multiplied by C3. Okay, C3. Okay, so the Cx equals to 0.25 microfarad. Okay, that is for Cx. And then we have to calculate the dissipation factor is given by, okay, that is formula to calculate the dissipation factor lah. So for Maxwell and Hey, normally we use the Q, okay? We use to measure the Q, but for sharing, we have to measure the D lah, okay, dissipation factor. So this one, the formula, the standard formula for D is equals to omega multiplied by Cx and multiplied by Rx. Okay, so for Cx and Rx already calculated here. So just multiply, and then you can get like this lah. Okay, so for D equal to 3.1416 lah. Okay, similar like pi. Okay, that means D equals to pi lah. Okay. Okay, last one for the AC bridge is the Wien bridge. Okay, Wien bridge. So this is last part for AC bridge. That I mentioned to you. For AC we have 4 types. Okay, first is the Maxwell, second is the Hay. All right, Maxwell and Hay will be same to measure the inductance. Okay, but the difference is to between two bridge is to measure the low and high Q factor. Okay, for sharing bridge will be measure the capacitor. Okay, measure the capacitor, and also the Wien bridge will be measure the capacitor, and also for Wien bridge we can measure the frequency. All right, so that's why you can see this one. So for bridge is used to frequency measurement. Okay, that's why we can use for measure the frequency and to measure the unknown capacitance with great accuracy lah. Okay, I think will be standards. Okay, based on the Wheatstone bridge, but the difference you can see here. Okay, this one similar like Hay bridge. All right, so let's go for the last. For the last bridge, there is this Wien bridge. Okay, you can see this one. All right, so that I mentioned to you. So this will be measured the unknown capacitance and also to measure the frequency lah. Alright, so you can see this one. So I think this Yuan bridge actually similar like Hay bridge. Okay, alright. So the difference is okay on this part lah. Okay, on this part. Okay, so before this for Hay bridge we only have the R3, but this one we have the parallel of capacitor lah, C3, and also Z4 we just only have the R4. Okay, R4. So the equation will be same based on the balance equation. Okay, Z1 multiplied by Z4 equals to Z2 multiplied by Z3 lah. And then just substitute the value of Z1, Z2, Z3 and Z4, so you can get the equation lah. Okay, you get the equation. So this one lah. Alright. Okay, so that's why from this one we can compare reals and reals, imaginary and imaginary lah. Right, at the end you can get this one. So R3 over R4 equals to R1. Sorry, this is R2 over R4 equals to R1 over R3 minus C3 over C1. Okay, so that's the equation lah. Right, so this one we can use to measure the C3 lah. Okay, C3, and then we also can measure the frequency using this formula. Okay, so the formula is actually omega is equals to 2 pi f. This is standard formula for omega. So to calculate the omega, we have to use this formula lah, based on this derivation. So 1 over omega C1 R3 equals to omega C3 multiplied by R1 lah. From this one derived, we can get the omega. So omega equals to 1 over square root of C1 R1 C3 R3. Alright. So I mentioned to you the omega is the formula of omega is 2 pi f lah. 2 pi f. Okay. And then after you get this one omega, you can calculate the frequency. Alright. So that means frequency equals to omega over 2 pi. Okay. Over 2 pi. That is formula lah for calculate the omega. Okay. So this some example. Alright, so given here, you can see this one, the value of R1, C1, R2, F, okay, frequency, and R4 lah. And then for this one, you have to calculate the R3, alright, and also the C3 lah using this formula. So for example, the value for R3 equals to R4 divided by R2 multiplied by R1 plus 1 over omega power of 2 R1 C1 power of 2 lah. Okay. So this is for calculate the R3, and then to calculate the C3, okay, the C3 equals to R2, okay, divided by R4 multiplied by C1 over 1 plus omega power of 2 R1 power of 2 and C1 power of 2 lah. And then you calculate it, you can get this the value of capacitor. Okay, the capacitor lah, there is a 20.3 picofarad. Okay, and also can use this formula lah. Also can use this formula lah to calculate the C3 equals to 1 over omega power of 2 C1 multiplied by R1 multiplied by R3 lah. Okay. Then last but not least is the conclusion lah. Conclusion for AC bridge. Okay, that I mentioned to you. Alright, so on the AC bridge, okay, we have 4 types of the AC bridge. Okay, so we have the Maxwell's bridge. Okay, Maxwell is to measure for unknown inductance for low Q factor, right? Low Q factor. Alright, and then for Hay bridge to measure the inductance, but for high Q. Alright, so you can see the difference between the Maxwell and Hay is on the Z1 on the Z1. So for Z1 for Maxwell is the parallel capacitor parallel with resistor, and for Hay bridge is a series. Okay, capacitor series with resistor. Okay, the rest is same. Okay, for next is the sharing bridge, is to measure the low capacitor with low voltage. Okay, and Wien bridge is to measure the capacitance and also can measure the frequency. Alright, so the difference between the sharing bridge and Wien bridge is on the Z1. Okay, on the Z1 impedance 1, this is parallel. Okay, capacitor. Okay, a variable capacitor parallel with R1, and this one will be capacitor parallel with variable resistor for R1. Okay, and also another one here. So So it's a capacitor. So this one only capacitor for sharing bridge, and for WN bridge, capacitor parallel with resistor, variable resistor R3 lah. And also R4 will be R4, Z4 will be R4, and this one will be RX parallel with CX. Okay, the rest will be same lah. That is the four main bridge for the AC. Alright. Okay, that's all for AC bridge. Okay, that's the every okay, for every bridge you have to remember the formula. Formula. For example, you go for okay. So for example, for RX, okay, from Maxwell, you have to find the RX equals to okay R2 multiplied by R3 divided by R1. Okay, and then for LX equals to, all right, so C1 multiplied by R2 multiplied by R3, and then for calculate the Q equals to omega C1 R1. Okay, that is formula for Maxwell. You have to remember lah. Okay, for RX, okay, for Hay bridge, okay, so equals to Rx equals to omega power of 2, okay, C1 power of 2, all right, R1, okay, R2, R3, okay, divide by, okay, 1 plus omega power of 2, R1 power of 2, C1 power of 2, okay, and then we have to calculate the Lx. Lx equals to R2 multiplied by R3 C1 divided by 1 over omega power of 2 R1 power of 2 C1 power of 2. Okay, and okay, from this one also we can calculate the Q lah. Okay, so the Q come from this one, from Lx actually. Lx equals to R2, okay, R3 C1 divided by, okay, 1 plus 1 over Q power of 2. Okay, from this one you can calculate the Q lah for Hay bridge. Okay, next for the sharing bridge, okay, for sharing bridge, so to calculate the Rx equals to R2 multiplied by C1 over C3. Okay, C3, and then to calculate the capacitor, Cx is the R1 divided by R2 multiplied by C3. Okay, and then to calculate the dissipation factor, okay, is the D is the omega, okay, Cx Rx. Okay, so omega multiplied by Cx multiplied by Rx lah. Okay, and then for Wien bridge, okay, you have to measure the okay, measure the R3 for example. Okay, R3, you can use this formula, R4 divided by R2 1 over omega power of 2 R1 C1 power of 2 lah. Okay, that is formula for calculate the R3. And also you can use this one lah, the formula for C3 given, okay, 1 over omega 2 C1 R1 R3, right? And from this one we have, maybe you can measure the frequency lah. Actually frequency come from 2 pi f. Omega is equal to 2 pi f to find the frequency. Okay, omega divided by 2 pi f. Okay, 2 pi, and then omega is 1 over square root of C1 R1 C3 R4 lah. Okay, so that is a formula that you have to remember lah. For every bridge, they have the different formula. For example, the Maxwell. Okay, Maxwell, this formula to calculate the, but this is standard for Maxwell's. Okay, all right. And then for hay bridge, okay, you have to calculate the RS, LX, okay, LX, and okay, and then the Q lah. Okay, and then for sharing, you have to calculate the RX, CX, and also the D, the dissipation factor. All right, and then last, the wind bridge, you have to measure the R3, C3, and also you can measure the frequency lah. Okay, if not given, we have to calculate the frequency. Okay, that's all for AC bridge. All right, so okay, so that's why you have to remember lah this one. Okay, so every bridge they have the different formula. Okay, you have to remember this one. Okay, so that's all for chapter 6. Okay, so thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.